Hi guys, so in this video I'm going to answer question 5 from the 2021 Statistics Edexcel exam. So this was if we just scroll up, the paper 3 exam from 2021, and I thought this is quite a hard question to do. So one of the harder questions. It's the second last question on this exam paper. So this question 5, and it's about normal distribution and also a bit of hypothesis testing as well at the end here. So there's a couple of questions in here which I think are quite interesting. So I thought this would be a good question to work on, especially if you're watching this a couple of days before your paper 3 exam in 2023, because I'm recording this right now in 2023, a couple of days before your exam. But regardless of whenever you're watching this video, hopefully this will be helpful. So question 5, so you've got the heights of females from a country are normally distributed with a mean of 166.5 centimeters, standard deviation of 6.1. So what I'm going to do immediately when I see a piece of information like that is I'm going to call X the height. So X is going to be the height. Sorry, let me write this again. Just going to move my thing across. So let me write this again. So it's the height of a randomly selected. It's so hard to write on this on these Edexcel papers using my pen tool. I just want to be as neat as possible, so just bear with me and let me try and use my neatest possible handwriting. Right, so this is the height of a randomly selected female from this country. So it's really important. Well, I mean, you probably won't lose a mark for it, but I personally in the exam would give a definition for all of my letters, so all of my variables I introduce. So this is the height of a randomly selected female from this country, whatever it may be. And yeah, we've got a distribution where X is a normal distribution, 166.5 as a mean, and a variance of 6.1 squared. So I spoke to a couple of students about this. Just remember, your variance is the standard deviation squared. So take the square of the standard deviation to get your variance. So your variance is 6.1 squared. I've also had a couple of students as well mention why don't you just put like the standard deviation? Why do you have to put the variance in there? You don't you don't need to worry about that. You just need to know that it is what it is. It's basically to do with how the normal distribution function is like what the equation looks like of that function. But again, you don't need to know about any of that stuff. Anyway, so question part A. I mean, we're told here that 1% of females in this country are shorter than K centimeters. Find the value of K. So the really important point with this question is that we're being told in this sentence here that the probability that your height, so the height of a randomly selected female, is less than K is 1%. So the probability that the height of a randomly chosen person from this country is 1%, so 0.01. And we don't know what that K value is. So what we're going to do now is use our inverse normal distribution. So remember, the inverse normal function on your calculator gives you values on the x-axis of your distributions. You've got like a normal distribution like this. This is your x-axis. An inverse function tells you numbers on your x-axis. So just like in pure maths, remember, an inverse function tells you numbers on your x-axis. Same thing here. We've got like your mean in the middle there, which was 166.5. You've got K. So the probability you pick someone with a height less than K is 1%. So you've got a really small area down there, 1%. You've got this K there that we don't know. So we're going to go to inverse normal. You're going to put into your calculator area equals 0.01. So remember, your calculator, when you put an area into your inverse normal function in your calculator, the area takes the left tail. So it takes the area, the way your calculator is programmed is that it takes the area on the left side of the distribution. So not this right side area, it takes the area on the left tail, the left side of the distribution. So if you were to put into your calculator 0.99, then basically what your inverse normal is going to tell you is going to tell you this x coordinate down there with 99% of the area to the left. Sorry, 99% of your area to the left of that. So again, really important. Your area in your calculator is programmed on the left side of your distribution. Do remember that. Right. So then your mu value, your mean, is going to be what it says in the data. So 166 6.5, and your sigma is the standard deviation, so 6.1. So we're going to plug those numbers into our calculator. We're going to find out what we get. So distribution, normal distribution, inverse normal, area 0.01, sigma 6.1, and our mu is 166.5. What do we get? So we get a k value. So remember, when we plug this data in this calculator, we get the k value that we want, and we get k equals 152.321 decimal place. So that's going to be our k value. So that's part A. So now let's go to part B. So part B, so find the proportion of females from this country with heights between 150 centimeters and 175 centimeters. So now what we just do here is just a bog standard probability calculation. Well, I mean, I say bog standard, your calculator does a bog standard probability calculation. So what we want to do now is basically with this part B is you want to find the probability that the height of a randomly chosen person is between 150. So X is trapped between 150 and 175. So proportion probability, it's the same thing. So we want to find the probability that we pick someone with a height between 150 and 175. So you want to work out an area. So you want to use the normal CD function. So remember, CD, when you're using that normal CD function, we're thinking about areas under that curve. So basically what your calculator is doing is it's integrating the area under this normal distribution function, this curve here. It's integrating the area under that curve. Obviously, this function, this normal distribution function, is very, very, very advanced to integrate by pen and paper. So that's why in stats, in A-level maths, you get your calculator to do it for you. So, okay, so what we're going to do, we're going to go to normal CD. Again, I'm just going to write out the probability we want to calculate. So X is between 150 and 100 and what was it again? It was 175. Okay, so your lower value, so you're going to go to normal CD. So remember, CD stands for cumulative distribution. So cumulative accumulating area, that's the way that I like to think about it. So we're accumulating area under this graph. And again, if I just draw like a diagram just so I can illustrate to you guys what's going on here, you got 150 maybe there, you got 175 maybe there. We want to find the area under that graph. That's what the normal CD function does. So your lower is going to be 150. Your upper number that you put into the calculator is going to be 175. Your sigma is the same sigma we had before, so it's this 6.1 in the question. Your mu is the same mean as before, so 166.5. Plug all that into your calculator, and we get an answer of, let's see what we get, distribution, normal CD, lower 150, upper 175, same mu and sigma as before. So we're getting a p-value of 0.9148. I'll stop there to 4 significant figures. So that's what we get to 4 significant figures. So that's the probability you pick someone with a height between 150 and 175 centimeters. So that's part B done. We've done that part. Now, a female from this country is chosen at random from those with heights between 150 and 175. So what we're going to do is we're going to forget everyone who's got a height less than 150, and we're going to forget everyone who's got a height more than 175. We're just going to focus on these people here. So let's draw a graph. Let's look at our graph here. We're not, we couldn't care less about these people down here with heights less than 150. We don't care about these people who've got heights bigger than 175. We're only going to pick our sample from these people with these heights between 150 and 175. So that's what the question is saying. So basically, this is kind of like a conditional probability question. It says find the probability that her height is more than 160. So we want to pick someone with a height of more than 160, given that this person has a height between 150 and 175. So what we've got here is basically conditional probability. Okay, so we want to pick someone with a height between, so we've out of all the people with a height between 150 and 175, we want to pick someone who's got a height bigger than 160. So let's just write this out in words, just so our brains can process what's going on. So out of those with heights from 150 up to 175, we want to pick someone with a height greater than 160. So think about this again. Given that we pick someone who definitely is between 150 and 175 centimeters, we need to pick someone with a height bigger than 160. So this is basically a conditional probability question. So we want to find the probability we pick someone with a height bigger than 160, but given that the height is trapped between 150 and 175. So this is a conditional probability question. So using our conditional probability formula, so remember our key formula, I'm actually just going to write this down here just so we, don't forget. Probability of A given B is equal to probability of the intersection of A and B over probability of B. So this is equal to the probability that you pick someone with a height bigger than 160 and their height is between 150 and 175, divided by the probability that you pick someone with a height between 150 and 175. So that's what we want to calculate. Now, the bottom of this fraction is quite simple because we just actually worked that out like up here. So that's going to be our bottom. Let's actually just write this in. So we want the probability that x is bigger than 160. I'm going to try and write a little bit smaller so I can fit this all in. Intersection with 150 less than x less than 175, and divide this by the number we got before, which was this 0.9, can't remember the number now, 0.9148. Okay, let's write that there, 148. Now, how are we going to calculate this top probability? So let's just think about this logically. So let's have our number line. Let's draw like a number line. I think this is going to help us out. So number line, we want to pick people with, obviously we're picking people who have heights between 150 and 175, but we want to pick someone with a height bigger than 160. So we got 160 on our number line there. So we want to pick someone with a height bigger than 160, and they've got to be between 150 and 175. So logic, bit of common sense. We want to pick someone who's got a height bigger than 160, and they must be between 150 and 175. So we want to pick someone with a height between 160 and 175. So the probability on the top is going to be the probability. So let's just write this here. So we want to pick, so the intersection between being bigger than 160 and being between 150 and 175 is this region on the number line here. So again, let's think about, again, I'm just going to repeat it as slowly as possible so we can think about this logically. The probability that you pick someone with a height bigger than 160 and also a height between 150 and 175 is exactly the same as the probability that you pick someone with a height. So this is exactly the same as the probability that you pick someone with a height trapped between 160 and 175. Hopefully that makes sense. So again, we have to pick someone between 150 and 175 because that's our sample, but we need to pick someone who's got a height bigger than 160. So on that number line, we must pick someone who's got a height between 160 and 175. So therefore, our final answer, so our answer to the question, I'll just go back to blue ink again. So answer is going to equal the probability. So this was our numerator. So probability that x is between 160 and 175 divided by the probability that we pick someone between 150 and 175. So this number down that. I'll just rub this circle out. So 0.9148 on our bottom. And how are we going to calculate this top probability? Well, remember that we can just use the calculator to do that. So this is normal CD, so we're working on area. So probabilities are areas under curves. So we're going to go to normal CD. So normal CD. We're going to go to our calculator. Our lower number is 160. Our upper number is going to be 175. Our sigma, the same as before, 6.1. And our our mean is 166.5. Let's plug that into our calculator. Let's see what happens. And if I do that, I'm going to get 0.774 9 to 4 decimal places. So our final answer is going to be equal to, so 0.7749 divided by 0.9148. And this is going to be equal to, let me do this on the calculator, 0.7749 divided by 0.9148. So I'm going to get 0.847. So we've got about an 85% chance of picking someone. So out of all these people with a height between 150 and 175, we've got about an 85% chance of picking someone with a height bigger than 160. So a height between 160 to 175 out of all of these people with a height between 150 and 175. So hopefully that makes sense. But again, do leave a comment if that does not make sense. So that's part C. Now then, the last part of the question, we're now going to do our hypothesis test. So we've got the heights of so the heights of females from a different country are normally distributed with a standard deviation of 7.4. Mia believes that the height of the females from this country is less than 166.5 centimeters. Mia is going to take a random sample of 50 females from the country and finds the mean of her sample to be 164.6. Carry out a suitable test to assess Mia's belief. We've got to state our hypotheses and we've got to use a 5% level of significance. So basically, again, significance level, all that means is that we're going to do a test. And basically, in this data collection test that we're doing, we're going to say, okay, we're going to specify that the probability that we reject the null hypothesis is 5%. That's basically the idea of what's going on here. So let's write down our hypotheses. So part D to the question. So H0 is always our initial, like our status quo kind of assumption. So we're going to assume, so we're trying to test whether the mean is less than 166.5. So the status quo assumption is just to assume that the mean is still 166.5. So mu is equal to 166.5. Now our alternative hypothesis is what we're trying to test. So again, if we just read, we interpret the language in the question, we want to test. So we're doing this, we're collecting the data to do this test. So our data is going to test whether the mean is now less than 166.5. So now we're doing a one-tail test. So now the mean, we're testing whether the mean is actually less than this 166.5. So that's what we're doing. Now, obviously, to do a hypothesis test, we have to assume H0. We've got to assume the null hypothesis. We've got to assume that the mean is 166.5. That's what we've got to assume. Otherwise, we can't do any calculations. So we've got to assume that our null hypothesis is true. So we're going to assume H0 is true. So that means that we've got, you know, again, if we call X to be the height of a randomly selected person, so X is going to be the height of randomly selected, sorry, let me write that L again. So randomly selected. Oh no, my pen stopped working. Let me just plug in my tablet in and out. That's even the right word. So randomly selected. Oh no, my screen is not loading up. Oh, this is a real pain. Come on. I really don't need this. I'm trying to record a video. Right, let's try. Right, let's try. Okay, there we go. Right, it's done its thing now. Right, now let's type. Let's write in. Let's get the pen back. There we go. So a randomly selected. So the height of a randomly selected female is X. So assuming H0, so assuming our null hypothesis, like our original kind of assumption. So assuming H0. That means that X is a normal distribution with a mean of 166.5 and a sigma value of, so if we read the question again, what was our sigma value? So our standard deviation of this different country is 7.4. Okay, so our sigma is 7.4, so our variance is 7.4 squared. So that's the height of a randomly selected female. So one randomly selected female. Now, we're not just selecting one random female, we're selecting 50. So we're selecting 50 females. And what did we do when we selected these 50 females? We calculated the mean of those 50 females. Okay, so let's think about the distribution of the mean. So when we do a normal distribution hypothesis test, we're not just looking at the distribution of one random female. So remember, this distribution is the distribution of one female, so one person. We want the distribution of the mean of 50 people. So let's make this really clear. So we want to find, sorry, again, my handwriting is absolutely awful, so please do bear with me. So we want to find the distribution, so the distribution of the mean of 50 randomly selected females, because we're not just gonna, so when we collect our data, we're not just gonna pick we're not gonna pick one person. We're collecting 50 pieces of data and we're taking the mean of these 50 pieces of data. So we want to, so we got the distribution of one female, but what's the distribution of the mean of 50 females going to be? So we've got all these females, so you've got one female, so I'll call this X1. We've got another female X2, we've got another female X3, we've got 50 of these females up to our 50th one, and we're going to divide that all by 50. So we're going to divide that all by 50. So how does this work? So this is, I'm going to call this distribution here X bar. So our X bar distribution, capital X bar distribution. So we're going to add up our 50 females, divide by 50. What is the distribution for this? So hopefully you would have seen in class that the mean, so the distribution of the mean of normal distributions has the same mean as one person. So the mean doesn't change. So I mean, if you think about it, like every single one of these normal distributions has the same mean, because you got 50 females of the same mean distribution. Then you're dividing it by 50, so you're adding up the same means and then dividing that total by 50, you get the same mean as before. So your mean is unchanged. So the mean of the normal distribution for the mean of the 50 females in the sample is still 166.5. But your variance changes. You've got to remember that your variance changes. So the variance before was 7.4 squared. When you take a sample of 50 normal distributions, you take the mean, your variance is divided by the sample size 50. Now, you don't need to know the ins and outs of why that is. Unfortunately, you just have to learn it. I mean, to be honest with you, what I'm going to do once the A levels, so this is again, this is 2023, preparing for the 2023 exams. What I'm going to do this summer, in summer 2023, is I'm actually going to do videos where I basically go through more advanced topics in maths. So kind of topics, bridging topics between A-level maths and university maths. And I'm actually going to go through, one of the topics I will go through is explaining why, when you take the mean of a set of normal distributions, you divide the variance by the sample size. So you just got to remember that the distribution for the mean of a set of normal distributions, the variance is just reduced by a factor of the sample size. So whatever your sample size is, divide by your sample size. So the sample size in this question is 50. If it was 100, you divide the variance by 100. If it was 10, you divide the variance by 10. You divide by your sample size. So I'm just going to make a note of this, that you divide your variance by your sample size when you do your experiment. So sample size. Okay, right. So that's our distribution for our mean of our 50 normal distributions from the data that we collect. Okay, so then now what we're going to do is we're doing a 5% level of significance test, and it's a one-tail test. So again, I'm just going to make this really clear. This is a one-tail test. Why is it one-tail? Because we've got an inequality sign there. So we're looking at the left tail of the distribution. Less than sign means we look at the left side of the distribution. Bigger than sign means we look at the right tail of the distribution. So let's draw like a rough sketch of what we have. So we've got our so assuming H0, so assuming our H0, because again, to do a hypothesis test, we have to assume H0. We've got a mean in the middle of 166.5. We've got a normal distribution like this. And what we've got is we've got basically, we're doing a one-tail test on the lower side of the distribution because of the less than sign. We're looking at the left tail. And basically what we're saying is, okay, so when we collect our data, and we calculate the mean, which we did. So we calculated the mean back here, didn't we? Well, the question did. The question told us that the mean in our sample was 164.6. So basically what we want to do is work out the probability that we get less than that mean, because we're looking at the left side of the distribution. So our significance level is 5%. So that's 5%. So this here is our critical region. So our critical region there. So the critical region is the set of values on the x-axis. So this is our x-axis. It's the set of values on our x-axis that are so far away from the mean that we have to reject H0. So we have to reject our assumption. So this assumption must be bogus because, you know, we're too far away from the mean. That's kind of the idea. So the probability that we reject H0 is 5%, assuming that H0 is true. So what do we get from our data? And I'll call this lowercase x bar. So we collected our sample of 50 females, we took their heights, we got their mean, and we got this piece of data here. So the mean of these 50 people was 164.6. We just checked that that was the right number. Yeah, 164.6. Okay, right. So what we need to do now, we're looking at the lower tail of the distribution. So we need to find the probability that this mean distribution, so remember we're talking about this mean normal distribution, we want to find the probability that this mean distribution is less than 164.6. So what's the chance? I mean, what's the likelihood that we pick? So assuming that our initial belief was true, assuming that the mean is actually really 166.5, what is the likelihood? Well, sorry, not likelihood. I've got to be very careful about that word likelihood. What is the probability that you select someone, so that you select out of your sample of 50, what's the probability that you get a mean less than 164.6? What is the chance you get that? Now, if this probability is absolutely tiny, such a small probability, it tells us that, I mean, this H0 is probably not true, because basically to do this calculation, we have to assume H0. But if we assume H0 and we get a probability that's so unlikely, then it would suggest that our initial assumption was unlikely. So what we want to do now is calculate this probability, and it's an area. So remember, this is an area. So we're working out probability, which is the area under this normal distribution curve. So what we're going to do is we're going to go to normal CD on the calculator. Our lower value is going to be something really massive and negative. So it could be like negative 10 to the power of 10. Our upper value is going to be this 164.6. Our sigma is, remember, the square root of our variance. So what's our variance? So this is our variance up here. So let's just make a note of this, that this is the variance. So 7.4 squared over 50. So our sigma is going to be the square root of that. So square root of 7.4 squared over 50, which is equal to 7.4 over the square root of 50. So we're going to say that sigma in the calculator is 7.4 divided by the square root of 50. And then our mean is the mean there. So 166.5. So we're going to plug all that data into the calculator. And let's see what we get. My calculator switched off. Let me turn it back on. So distribution, normal CD for the area. So our lower number, something massive and negative. So a massive negative number. Upper value, 164.6. And then our sigma, so we're going to do 7.4 divided by the square root of 50. And our mean is the same mean as before, 166.5. Execute all that. Now, you should get this probability here. So we're going to get a probability of 0.0347. So that's our probability. So the probability that you take a sample of 50 people and the mean is as low or lower than the mean that we got from our data, 164.6, that is about 3%, so about 3.5%, so 3.47%. Now, this probability is very low, and in fact, it's lower than 5%, so it's a very low probability, and it's lower than this 5% significance level. So what does that mean? Let's go back to our graph here. I know that this graph looks a bit of a mess. So we got our critical region here, 5% of the area on the left tail down here. Now, that tells us that 164.6 must be somewhere in our critical region. Why? Because the probability that we get less than 164.6 is less than 5%. So it's 3. This is like 3.4%. So 3.47%. So obviously, if that's the area to the left of 164.6, then obviously this 164.6 must be to the left of this critical value there. So that's our critical value there. So it must be in the critical region. So the probability of getting something this low was so tiny that it was less than our significance level. So it was so unlikely. So if we get such an unlikely probability, so if the probability of getting what we got from our data when we collected our data through our experiment, if it was so low, then it tells us that our initial assumption H0, so our initial belief that the mean is equal to 166.5, is so unlikely. So therefore, what we've got to do is we must reject H0 because this probability is too tiny. It's so unlikely that we got what we got from our data. So remember, we did the experiment, we collected our data, we took the average. If H0 were true, it would be so unlikely to get that data that we got. So the data we collected was so unlikely if we assume that the mean was to be 166.5. So we would have to make the conclusion that it's unlikely that the mean is 166.5 because our data suggests that the mean is too big. The mean should be lower. So we're going to reject H0, and then I'm not going to have a lot of room for this, but you want to write your conclusion. So therefore, there is sufficient evidence. So sufficient evidence to suggest, that mean heights, so mean heights of females, sorry, my S is not looking very good, suggests that mean height of females in this country is less than 166.5 centimeters. So that would be our conclusion there. So that answers this question number 5 on this 2021 stats exam. Hopefully that helps you out, especially if you're watching this in 2023, a couple of days before your paper 3 Edexcel exams. Hopefully that was helpful. And of course, if you're watching this in the future, hopefully this helps you understand a bit more about the normal distribution and also normal distribution hypothesis test. So thanks a lot for watching and good luck with your revision.